So the next topic is about cost of quality. So we can tell the cost of quality as a methodology that allows the organization to reduce poor quality. That means the quality of the organization's products, services, and that results from internal and external failures. So in the process improvement efforts, quality cost or cost of quality is a means to quantify the total cost of quality related efforts and deficiencies. So first it was introduced by Armand V. Febingham in 1956 at Harvard Business Review article. If you have such information, it allows the organization to determine the potential savings to be gained by implementing process improvements. So what is the cost of poor quality? Or in other words, we call it a COPQ. The cost of poor quality can be termed as, we can define it as the cost associated with the providing poor quality products or service, and there are mainly two categories, that is appraisal cost, internal failure cost, external failure cost, etc. So here so the next point is the ways to improve the quality. So there are mainly three methods we used for the improvement of quality. First one is PDCA or PDSA cycle. It's an iterative four-step management method used in business for the control and continuous improvement of process and products. It is also called as Deming Wheel after the originator. It's a circular, never-ending problem-solving process. So in other words, we can call it as like it's Deming's wheel or Deming cycle, Deming circle, Deming's wheel or Shewhart cycle or control cycle or control circle. And another version of this PDCA or PDSA is OPDCA, that is O stands for observation. So this is a model for improvement, provides a framework for developing, testing and implementing changes leading to improvement. It is based on the scientific method and moderates the impulse to take immediate actions with the wisdom of careful study. Second one is about seven tools of quality control. So we use the pictorial representation to provide or to describe the quality or quality difference or the difference from the quality standards or quality plan, etc. Third one is quality function deployment. It is nothing but converting the customer's requirements into design specific. So PDCA as plan, evaluate the current process, collect the procedures data and identify the problem, develop an improvement plan, performance objectives, etc. Do means implement the plan on a trial basis. Study or act, that means collect the data and evaluate or analyze against the objectives, and act, communicate the result on the trial basis, and if it is successful, implement the new process. So this is about a PDCA or PDSA cycle. So the seven tools of quality management introduced by Kaoru Ishikawa. So he developed the seven tools, seven basic visual tools of quality so that the average person could analyze and interpret the data. Most of the companies worldwide, managers of all levels and employees, they are using these tools. They are like check sheets, fishbone diagram, run chart, Pareto charts, flow charts, histogram, and scattered diagram. Okay, so starting the check sheet. So it says structured, prepared form for collecting and analyzing data, and it's a generic tools that can be adopted for a wide variety of purposes. So in other words, a check sheet is a form or document used to collect data in real time at the location where the data is being generated. So this is an example for the check sheet. So this indicates the problems and weekly status, like for example, first week, second week, third week, and fourth week. So the problems are being noted, like network problems in the first week twice, in the second week it around 7 times, third week around 4 times, fourth week around 3 times, a total of 16 times in the 4 weeks status, and server problem, email problems, server access problems, etc. Second one is the histogram. So this is we can able to tell it is one of the most commonly used tool or used method for showing frequency distribution or how often each different value in a set of data occurs. So it's a bar graph that shows the frequency of data. And it can be termed as it is used to summarize or graphically summarize and display the distribution and variation of the process data set. So here is an example for the histogram. Then comes the third one, Pareto analysis. It's a bar chart that shows which factors are more significant. So it can be termed as a bar table and line table that graphically sums the group of data. The data may be sometimes grouped to cost, time, errors, etc. Bars in the chart describes the value in declining order. There is a highest bar at the left hand side and the lowest bar in the right hand side, and lines represents the aggregate total. This is the example for the the Pareto chart. Then comes cause and effect diagram. So it can be also termed as a fishbone diagram or Ishikawa diagram. So he introduced or he developed this in 1943, and it is identifies the many possible causes for an effect or problem, and sort or arrange the ideas into useful categories. So it's a fishbone diagram. So it indicates the causes, that is environment, material, man, equipment, and method. These are all the main causes, and the sub causes are like, for example, environment, limited space, small library, cabinets are overcrowded, then material, unclear writing on drawing are put under wrong category, etc. So these are all the causes, and in the right side we can see at the end of the arrow it's a result. So cause and effect diagram, it is exactly like a fish bone. That's why it is also called as the fishbone diagram. Then comes control chart. So control chart is generally used to study how a process changes over time. It compares the current data to historical control limits, leads to conclusion about whether the process variations is consistent, that is in control, or is unpredictable, that is out of control, affected by special causes of variation. So generally the control chart is having two limits, that is upper control limit and lower control limit. See here, we can have this upper control limit and lower control limit. See, the best example we can tell about the diabetic level. So just imagine if it is below the normal level or above the normal level. That means there is a range for diabetic. For example, if you are telling like 70 on 40 or 80 on 20. If it is below 80, it's a problem. If it is above 120, then also a problem. So in order to maintain the diabetic level, or in order to maintain non-diabetic level, the value should be between 80 to 120. That is between lower level and upper level. So how many experiments we do to make it into the process average or in the middle, that is the central line. So that much quality we can expect from the given product or service. So this is about an example. See, in the first experiment, that processes are not centered, means starting of the experiment, the processes are not centered, and it is not stable. And in the second category, we made experiments, we made many trials, and we tried to make it into the center, that is process are centered and stable. And then again, after doing multiple experiments, multiple trials, we made it into maximum to the center, that is additional improvements made to the process, and now we can tell that it is having the expected quality, it is having the quality that we expected. Then comes the scattered diagram. So it is a graphical part of numerical data on variable on each axis to look for a relationship. And here we can tell an example for the scattered diagram. So it pairs of numerical data with one variable on each axis to look for the relationship between them. If the variables are correlated, the points will fall along a line or curve. The better the correlation, the tighter the points. So in other words, we can tell the scatter diagram is graphical illusions that shows the relation between two variables. It's a quality management mechanisms in which data is described as a point, and each point outlined in the graph shows the value of the level and upright axis. Out of those couple variables, one variable is sovereign and the second variable is conditioned, and the first on the first variable. So it's also known as the scatter plot or scatter graph. Then comes flowchart. Like histogram, another most popular or well-known graphical representation is flowchart. It's a design which describes the overflow method or algorithm or a step-by-step manner related by arrow in different sectors. So these flowcharts are used for the description of organizational arrangements, logging systems, document work process flow, billing, deal flow, etc. So it enables, flowchart generally enables classifying of the exact flow of causes in the system. It is a measure of the process that will prevent or that will present information or understanding of what the method looks like and cast some light on the quality issues. So in short, we can tell a flowchart is a formalized graphical representation of a logical sequence, work of manufacturing process, organizational chart, or similar formalized structure. So this is an example for that, like start and end, then order burger, one fries, order for price, what the drink, so the conditions, and pay the cashier, and then comes the end. So then comes the characteristics of a quality employee. So there are many qualities every recruiter looks for, like organized, punctual, a team player, a positive attitude, and so on. So in addition to that, there are many the recruiter might not think of. Some like the employee should be honest, dedicated to quality work. They should have experience and skills. Generally, we call it as like a schooled and skilled, punctuality, energy, ability to work without disturbing or without creating problem for others. They should be able to take initiatives and their communication skills. So these are all the normal characteristics for an employee. In addition to that, some additional characteristics like they should have some computer skills, management skills, speaking skills, sales skills, and any other skills. Particularly since we are dealing with the projects, as I told you, if you remember in first chapter itself, to be a quality project manager or to be a quality manager, we should have a knowledge about PMBOK, organizational knowledge, project environment, and also interpersonal skills. So we can tell some 20 to 25 quality characteristics of a good employee. He should be a team player. He should be a good communicator. He should speak up, like taking the initiative. He should try to speak up in the meetings, then collaborate with their co-workers. they dress for success. That means dress for success means not like a neat dressing. That means they will always aim for success. They will always should have a take charge attitude. Uh, they should also gain the leadership opportunities. They should be on time, that is punctuality. Uh, Always they should think like a manager, not like an employee. Always think about the results. Don't try to compare yourself with others. Detail oriented, follow the trends. They always try to listen to the feedbacks, try to avoid gossips, know how to play the game. They are also should be ready to learn, try to attend the company events. Uh, they are comfortable with the pressures. They are always ask for help. They are adaptable. They are honest. They are optimistic. They are humble. They should be technical savvy, etc. like that. So a quality workplace. So when we are considering about the quality employee, the same way, the quality workplace is essential to keep your employees on track and work effectively and efficiently. An excellent work environment is marked by such attributes as competitive wages, trust between the employees and the management, fairness for everyone, and a sensible workload with challenging yet achievable goals. So the different ways to improve to motivate the employees or inspire the employees are: try to get the right team in place, communication with them clearly and regularly, offering educational opportunities, and recognizing and celebrating success. So that's all about this topic. Thank you.